Hello friends. So after solving many problems on multiplication by t property, now we are gonna solve or we are gonna apply that property on error function of root t. So let's see how to apply the property. So here we have to find out the Laplace of t into e to the power 3t error function of root t. Now guys, for this you have to go back because you should know what is the Laplace of error function of root t, and in the previous videos you can find out that I have given you the derivation of how to get the Laplace of error function of root t. So here I am not gonna derive it back, I am gonna use that value straightforward and get the answer. So let's first think about which property we must use here, and then let's see the formula of Laplace of error function of root t, which I had covered in the previous video. So here this question is in the form of t into f of t. So if you are considering these two functions together as f of t, then this will become t into f of t, and it looks similar to the multiplication by t property. But let's say if I take this e to the power 3t outside and t here, then this will become Laplace of e to the power 3t into t error function of root t. And guys, this looks like the first shifting property, that is e raised to at into f of t. So it means this problem can be solved by two methods, and I would recommend to use this second method. So according to second method, I am gonna consider this as f of t. Then I'll be getting value for Laplace of f of t, that is phi of s, and then we will substitute that phi of s in the final answer. So this is the first shifting property where we consider the function of this function as f of t, and for f of t we get the Laplace, we make it as phi of s, and from there we get phi of s minus a. So here a is 3, so we are gonna get phi of s minus 3. So let's start. So here I'll say here the f of t is t error function of root t. So let's find out Laplace of f of t, which will be our phi of s. So it is nothing but Laplace of t into error function of root t. Now guys, if you see this bracket, then it is matching with multiplication by t property because it is t into function of t. So by multiplication by t property, if the power of t is 1, this will be minus 1 raised to 1, d raised to 1, ds raised to 1. Phi of s, where phi of s is the Laplace of f of t, and f of t is the value which is given with t. So here f of t is error function of root t, and Laplace of that error function of root t is gonna be phi of s. So guys, here using, I'll say here using multiplication by t property, this is minus d by ds because the power of t is 1 into phi of s, and phi of s is Laplace of this, which is 1 upon s square root of s plus 1. So guys, here I am writing the Laplace of this directly because we have seen the derivation for Laplace of error function of root t in the previous video. Now let's find out derivative of this, and after finding derivative we will get Laplace of f of t, and which will be our phi of s, which we are going to use here for first shifting theorem. So let's start. So minus n as it is. Now here in the denominator we can see that this is given in the form of 1 upon x, and the derivative of 1 upon x is minus 1 upon x square. So this will become positive 1 upon x square. So s square, and square of root of s plus 1 is only s plus 1 into derivative of this value, that is s root of s plus 1. So to get the derivative of this term, here it is in the form of u into v. So guys, now I'm gonna use the property of u into v, that is u derivative of v plus v into derivative of u. So this will become equal to 1 upon s square into s plus 1 in bracket u, that is s as it is. Derivative of square root of s plus 1 is, so I will treat this as square root of x. So derivative of that is 1 upon 2 root x. So it will become 1 upon 2 root s plus 1 plus root of s plus 1 as it is, and the derivative of s is 1. So I'll close this bracket. Now let's simplify this. So here we will get 1 upon s square s plus 1. Now if I'll do the cross multiplication, here we will get 2 into root s plus 1. Root s plus 1 is 2 times s plus 1. So this s as it is plus 2 times s plus 1 upon 2 root s plus 1. Now guys, this is 2s plus s, that is 3s, plus 2 into 1 is 2 upon 2 into s square, 2s square. This is s plus 1 raised to 1, this is s plus 1 raised to half. If I multiply this, I'll get s plus 1 raised to 3 upon 2 by using laws of indices. And guys, this is nothing but my phi of s. So I got this value from the Laplace of f of t, that is Laplace of this t into error function of root t. And guys, now I'm going to use this value here in the first shifting theorem. So here I'll say, using first shifting theorem, the Laplace of e to the power 3t into t into error function of root t is equal to phi of s minus 3. And here I got the value of phi of s. So in phi of s, I'm gonna replace s with s minus 3. So this will be 3 times s minus 3 plus 2 upon, here we will get 2 times s minus 3 the whole square into, this will become s minus 3 plus 1. So s minus 2 raised to 3 by 2. And guys, this is the answer of Laplace transform of given function. So if you want, you can simplify the numerator as 3s minus 9 plus 2. That will become 3s minus 7, and the denominator will remain as it is. So here we got Laplace of this given function by using multiplication by t property and first shifting property. And I'm sure that you understood the way I've explained it. So don't forget to share it to your friends. And if you want to learn all videos together, then do visit to ekera.com, because that is the only place where you can find my videos. Thank you very much.